Hi, good morning everyone. So in previous classes, we have completed IPSC nomenclature of common compounds, and on that regard, I have given some assignment also, but I am not getting assignment from you people. And so I want you to send the assignments so that one I can come to know whether whether you people are following or not. So before going to today's session, that means today's session will be on types of reactions. Before going to this session, uh, many of you tried. In the last class, whatever I have given the assignment on that, you people have gave some answers. But see, dear students, okay, in a single compound, there may be two double bonds, no doubt, like this, no doubt. But try to write. See what I said before going to before going for the naming. One, we have to check whether the given compound is correct or not. But you failed while writing. Valency. In valency, you are not going with the valency. So whatever you have gave the answers, assignment, they are very good, and I am very happy that you people have tried something, right? So don't do like that. After writing one example of type 5 carbon or 6 carbon or 7 carbon, check the valency. Count the valency around a single carbon atom. You have to check each and every carbon atom present in the example. Then you start giving the name. Otherwise, the name will be wrong. So this is what I need to talk about yesterday's class. And in today's class, we will go with the types of reactions. In organic compound, we have four type of reaction. We have four type of reaction. Today we will go all the four type of reaction. So what are those means? Number one, addition reaction. Number two, substitution reaction. Number three, elimination reaction. Number four, which is very important, rearrangement reaction. Right? These are the four type of different reactions which we can see under the class of chemistry, that is organic chemistry. So commonly, why these many type of reaction takes place in our organic compound means, so organic compound has a capacity to show double bonded, triple bonded, as well as single bonded organic compounds. So that's why one we can see a different type of reaction in the organic compound, especially in case of carbon. So already you have studied these type of reaction in your lower classes. I will just give you a definition and try to explain by giving one example. So number one, addition reaction. The name itself indicates add. Addition reaction. See, the name itself indicates adding. That means what is this? The compound or group can be added, right, in a chemical compound. That means these chemical compounds may be, you can say, what is the main reason here why they will undergo into the addition type of reaction means, see, this type of reaction first of all takes place in a compound like unsaturation, very important, right? Saturated compound will not go addition reaction. Why? Because already they are saturated. That means here addition reaction, what we can see in case of unsaturation of both type. That means we can see this type of reaction in alkene as well as in case of alkyne. Alkene means double bonded carbon and alkyne is nothing but triple bonded carbon, I mean compound. So where we can add these compounds. See, but we will see one example like this. Then you can easily understand. CH2. See, the condition is only the unsaturated compounds can undergo addition type of reaction. So this is very important. CH2 plus H2. Then what will be the product? This is very important. So what we took? We took two reactants in which one is alkene, that means unsaturated compound. To that alkene, what we are adding with that alkene, H2. That means, see here, there is a pi bond, and already I have explained you, whenever there is a presence of unsaturated compounds, then there will be a presence of pi bond. And what is pi bond? Pi bond is nothing but very weak bond. Due to extension of overlapping. Extension of overlapping is very less in case of pi bond. So that's why this type of reaction can easily undergo into the reaction. So see, whenever this type of compound we are going to add in the organic compound, then you have to take care about one thing. What is that means? See, there are two hydrogens. Both these two hydrogen will not go and attack one carbon, single carbon, right? Whether it may be a addition or it may be a elimination, at a time one hydrogen can go and attack one carbon atom, simultaneously the other hydrogen will go and attack other carbon atom, but both the hydrogens will not go and attack one carbon atom. So this is the condition. So see, now this is a pi bond, right? The upper bond is pi bond. If we consider, then what happens if one hydrogen will go and attack on this carbon? Sorry. Among these two, if one hydrogen will go and attack on this carbon, see, now, and one more hydrogen, I will write completely, and one hydrogen will go and attack. Just assume, right? And this type of reaction only happens here. So now assume that one hydrogen is going on this carbon and one hydrogen is going towards this carbon. Now see, first of at the reactant CH2 actually, but one more hydrogen is coming on this carbon. So now the number of hydrogen becomes 3. Just to write down. Okay, don't go for this. Later I will explain. Double bond keep as it is. And now again one more. To this CH2, one hydrogen is attacked. That means CH2 becomes CH3. Now count the valency of carbon atom, which is very important. So now with respect to this carbon atom, forget about this. With respect to this carbon atom, 3, 4 and 5, right? And now here, with respect to this carbon atom, forget about this. 3 plus 2, 5. 5 valence. What is the valency of carbon? 4. That means 5 valency will not be seen in any carbon atom. So that's why what we will do, we will remove one bond, right? If I remove one bond, then now the compound is very well satisfied. See, these addition reaction can also be called as, you just compare this compound with this compound. So what is the difference here in this compound? I mean in alkene of type ethene, right? So in ethene, what we are seeing here, there is a presence of double bond. But in product, the double bond is converted into single bond. So this type of reactions are called as addition reaction. That means unsaturated, very simple definition. Unsaturated compounds are converted into saturated compounds. Very important. That means alkenes are converted into alkanes. Right? Alkenes are converted into alkane. So such type of reactions are called as addition reaction. I repeat, addition reaction, the organic compound like having double bond or triple bond, they very easily undergo into the reaction. Why? Because there is a scarcity of electron. So that's why they easily undergo into the reaction. So in particularly in this example, see, first what we took, we have took alkene in the form of ethene, and to this ethene we have reacted with the H2. That means H2 molecule, hydrogen molecule. So what I said, both these hydrogen will not go and attack on one carbon atom. This is very important, right? Either it may be elimination or addition that takes place one at a time. So that means one hydrogen will go and attack on this carbon atom, and the remaining one hydrogen will go and attack on this carbon atom. So thus now already we have CH2, CH2. So I kept like that only. Because of addition of one hydrogen onto this carbon atom, the number of hydrogen becomes 3, and now here that means double bond is converted into single bond. Why? Because one electron is given by see, in this compound we are having two electron scarcity. That means we have two less electron in this compound. So that means because and those two electron we got from two hydrogens. So that's why this bond is eliminated like this in this compound, right? So this is about addition reaction. So addition reaction, unsaturated compound are converted into saturated compounds are called as is called as addition reaction, right? So you check in your book, again you will get number of examples, right? So next is substitution reaction. Substitution means one atom or group is removed and to substitution reaction, onto that place atom or group are introduced, substituted, right? So substitution reactions are very simple reaction. Here substitution is nothing but, see, I will first I will write the example, then you can very easily come to know. CH3 CH2 Cl plus KOH, right? Upon reaction, now CH3 CH2 plus minus CH3 OH plus Kc. So this is called, according to reaction, this is called a substitution reaction. See, here we are not adding or eliminating, we are just replacing, right? See this compound, chloroethane we call, right? So this chloroethane undergo into the reaction in the presence of potassium hydroxide, KOH, right? So what happens is here, see, reaction is nothing but old bond has to break and new bond has to form. So that is nothing but the reactions. In the same case, right here, see, this bond has broken, right? This bond, I will write completely now here, OH. And here in this, the bond between potassium and hydroxyl group is broken down. So that means now what we got is, see, Cl has removed from this compound, and now because we have removed Cl, here the bond has to break. That means potassium has to break its bond with the OH. So the same thing will happen, and OH bond will be broken. And now this negative, because in from this group one negative character is going out. That means we have to add negative only. So in Cl place, see here, OH has K, and in the place of OH there is a Cl. That means what we have did is we have just replaced a atom, you can say atom or ion or a group with the other. That means here we are not going to add any compound, or here we are not going to add any ions or any atoms, anything. We are just replacing one atom or ion with the other atom or ion in this case. Such type of reactions are called as substitution reactions. Very simple. Again, see, just what we have did is, so in simple way, if you are not getting in terms of electronegativity, then I will make you clear now. See here, we have removed Cl, and Cl is nothing but negative charged species. In the place of Cl, what we have introduced? We have introduced a OH, right? That means we have removed Cl, and on the same place of Cl we have added OH. That means replacing. That is nothing but the substitution reaction, right? Here elimination or elimination or addition will not take place. Just simply we replace one atom or a group with the other. So such reactions are called as substitution reaction. Next, coming to the elimination reaction. The third type is elimination reaction. So the name itself indicates eliminate. Eliminate means to be removed or remove. Right? Very simple. See, I will write one example. You can come to know very easily. CH3 CH2OH, or else you can say it here CH2 CH2Cl in the presence of alcoholic potassium hydroxide. I will say what is alcoholic potassium hydroxide. So now the reaction becomes, the product what we get is CH2 plus HCl, right? Plus HCl we can say. So now, right, hydrogen was removed, and in case of that means here we have removed a Cl molecule. See, if I write open structure, then you will understand very easily. Right. Just observe this compound very clearly. So now what we have did is alcoholic potassium hydroxide is dehydrohalogenating agent. That means it not only removes the hydrogen, it will also remove halogen. Halogen means halogen group: chlorine, bromine, iodine, or fluorine. So those are called as, and they are represented by a letter called X. Right? So it will remove hydrogen as well as Cl. So that's why we have took this reagent as an alcoholic potassium hydroxide. Its duty is to remove the hydrogen as well as the Cl. So after removing hydrogen and Cl, how we got this product? That means, see, once these two removed, So now what is the compound? This. How double bond came? I'm just explaining that. So now after removing H from here and Cl from this carbon, what happens? Now check the valency. Valency is very important again. If you come to know what is the valency and how to check, then organic chemistry is very easy. So now see, with this carbon there are 2 plus 1 3 bond, right? Now what is the condition here? You check for this also. 2 plus 1 3. That means both the carbon atoms are having scarcity of electron. How much electron they have scarcity? 1 1. So that means if I introduce one more bond here, now you check. The product will be like this. That's why I have wrote this product and I have removed HCl. Right? So now see here. 2 plus 2, 4. This carbon is satisfied. With respect to this carbon, 2 plus 2, 4. So that's why I have wrote CH2, double bond, CH2. So I will write again a original compound, HCl. So here we have removed, that means we have eliminated the atoms or ions or groups. So that's why this type of reactions are called as elimination reaction. Before eliminating these compounds, what was the condition of this compound? There is, in between carbon and carbon there is a single bond. So that means saturated hydrocarbon. And now after removing these two, what was the condition now? There is there is a double bond. That means saturated hydrocarbon is converted into unsaturated hydrocarbon. Our single bonded compound is converted into double bonded compound. Such reactions are called as elimination reaction. This is just exactly opposite of what? Addition reaction. So you check some more examples for these three reactions. In the next video, we will see rearrangement reaction and the type structure of organic compounds. So try students and try to write the more examples. Thank you.